Okay, somebody asked me to do a quick little video on completing the square. Typically, I'll complete the square if I see an x squared and if I see an even number there. As soon as I see all these are even, I'd be okay with those. If I see something with an odd number there or a number out front, completing the square, you can do that, and there's some times where that's useful to do. But typically I would be just using this, and to solve that, rather than using completing the square, I'd use the quadratic formula because it's way easier. But somebody wants me to show how to do it, so I will give it a shot. Okay, so let's try this one. So 3x squared plus 5x. I'm going to immediately take the 2 over to the other side. Okay, now, if you're completing the square, you can't have a 3 there. So you have to get rid of the 3. The only really way to get rid of, well, there'd be a couple ways. You could factor 3 out, or you can take and divide everything by 3. Maybe that's what I'll do first. Fractions everywhere. Okay, these cancel, so I have x squared plus 5/3 x is equal to 2/3. Okay, lots of fractions, fun. Already I'm thinking, use that. Okay, now to complete the square, I have to take this b term, so 5/3, and I have to divide it by 2, and then I have to square it. Double fraction. So it'd be 5/3 divided by 2 squared, or if I do fractions here, this would be times the reciprocal of 2 over 1, which is a half. So it'd be whatever that is squared. So it'd be 5 over 4 squared, which is 25 over 16. Okay, so it'll be x squared plus 5 over 3 plus 25 over 16 is equal to 2/3. Now, I just added this thing in, so if I do it on one side, I have to do it on this side too. So I'm going to have to go plus 25 over 16 on that side. All right, so now I've made this a perfect square, so this will factor into x plus whatever 5/3 divided by 2 came out to be. 5/3 divided by 2, 5. Oh, this should have been a 3. How did it become a 2? Whoops. Third. So this 3 times 2, this would be a 6. And this would be a 36. Whoops. So this is, yeah, that's right. So this is a 36, and that's a 36. Whoops. All right. See how you can get into trouble with these questions, dealing with fractions and fighting with them. Okay. Anyway, so 5/6. So it'll be x plus 5/6 all squared is equal to this stuff. Now I'm going to make this into 36, so I'm going to take the bottom and multiply it by 12, because that'll give me 36. If I do that, I have to multiply the top by 12, so that'll be 24. So it'll be 24 plus 25 is actually 49 over 36. If you want, you can try that on a calculator, but it should come out to that. I'm doing it quick, so I might have made a mistake, like I've already done. Okay, now I use the square root principle, so it'll be x plus 5/6 is equal to the plus or minus square root of 49 over 36. It just so happened in this question that both of those are perfect numbers that I can take the square root of. So it'll be x plus 5/6 is equal to a plus or minus 7 over 6. Now we'll take the 5/6 to the other side. So it'll be x is equal to a negative 5/6 plus or minus 7/6. Now, since these are both 6, I might as well get both answers. So it'd be minus 5/6 plus 7/6, or minus 5/6 minus 7/6. So minus 5/6 plus 2/6, that would be 2/6, I think, which reduces to 1/3. So x is equal to 1/3. Or here, minus 5 minus 7 is minus 12. So minus 12/6, which when you divide, comes out to a negative 2. So those would be my two answers by completing the square. Had you done it with the quadratic formula, would have been way faster. And even more fast, even faster than that, you could actually factor that one. So 3x squared plus 5x minus 2 equals 0. You could factor it. And it'll be a 3x here and an x there, and then probably a plus 2 there and a minus 1 there. If you FOIL that out, I think it gives you this. So this one here would be 3x minus 1 equals 0. So 3x equals 1 and x equals a third. Same. And then on the other one, x equals minus 2, same as what we had down below. Okay, so three ways of doing it. If you wanted to complete the square in this question, and you did that and you got everything right down at the bottom, I'm giving you a major check mark and a happy mark, and I might buy you a donut at Tim Hortons. All right.